thank everyone that's showed up here tonight. I know it's the middle of the week and I know that people are excited about The Walking Dead. So I understand the sacrifice you've made to actually come here. Now, just a bit of forewarning, I'm an old school teacher, so I'm going to be wandering up and down here, so if it looks like you're falling asleep, I'll walk up next to you and I'll speak straight to you. So that way I'll keep you focused. And also, just bear in mind that the best kind of workshops and these kind of get-togethers are the ones where you guys are also engaged. So if there's any questions or anything like that, you lift your hand, and if someone else knows the answer, then you can also answer as well. This is an open forum, and I think this makes for the best experience that everyone can have. So, as Per Philip said, I come from a little company called Din Fabrikk, which I run on the side, and I'm also a global training manager in FMC Technologies in the Controls and Data Management Division. Now, about half of you know this because I know about half of the people in the room here. So I work with a lot of data handling, I work with the training, I work with the smartest that we have in FMC with regards to control systems and the data that's flowing in and out of that system. So naturally, I have an interest in big data. So I started Din Fabrikk about 2 years ago unofficially, and we registered it early 2016, and we've been in operation since. And we have a very interesting history, which I'll go into more detail a little bit later on, but it became very apparent very, very quickly that theoretically people had a good understanding and a grasp of what big data was, but practically how to apply this, there was a huge gap. And so receiving funding to do a study was one thing. To create a product that was actually usable and create value for the end user, that was something entirely different. So who am I? I'm probably Australia's greatest export. I moved to Norway about 11 years ago. I married a Norwegian lady, so I moved here for love, not for money. And I had to reinvent myself. I pretty much started from scratch. So I was born and raised in the Australian bush, quite literally, in the middle of nowhere. In a little place called Yarwun, we had about 200 people there, and it was literally snakes and spiders all over the place. So that's the kind of upbringing that I had. I was lucky enough to find my way to university. I survived my childhood years, many of us didn't, and I studied education. And this was probably one of the most useful things that I could have studied because it helped me to learn new skills and new subject areas quite quickly. And the great thing about education is that I took that with me into a bunch of different industries. So I worked as a teacher for a short while, but then I also worked in many of these other industries. For example, there was a heavy industry that was linked to construction and also oil and gas, and also the mining industry. I worked in the emergency services as well as a professional firefighter for quite a few years. I trained people in there as well. I worked in project management for universities and colleges, and I ran some projects there that were also linked to big data back in the early days of big data, before it became a common, cool thing to talk about. And of course I worked as a consultant as well. I've started 3 businesses now throughout my life. This one is the 3rd one that I've started, and the 2nd one in Norway. Of course I founded Din Fabrikk AS, and I also work as a global training manager in Technique FMC. So what do we do? Someone asked us this earlier today. I presented to Innovationsloftet earlier today about what it was exactly that we do. Because when we mention big data and we talk about that we work from acquisition to the result of that data, most people don't actually know what that means. So if we boil it down in the simplest terms, we do business analysis. We go and we have a look at your company and we analyse the business and the value stream. We have a look at what it is that you actually do and we put it down on paper. We look at your value stream with regards to where the bottlenecks and the issues are that you're running into. Basically, we have to figure out what problems you want solved. Because, you know, everyone's probably heard that saying that if the only tool you have is a hammer, then every problem looks like a nail. And this is the exact thing that we see. We see people catching on to this big data term and thinking that data will solve their problems. But all data does is it gives you higher resolution around the problem, but a decision still has to be made somewhere. And usually the decision is not automated. Somebody somewhere looking at that data has to make a decision. Then we also build hardware and software to support the solution. So I'll give you guys an example. We have a customer who's working in the forestry industry, and he needed a water-resistant drone with high flight time that could handle quite heavy load. So it needed to be able to carry dual sensors and run dual gimbals. There was nothing on the market at the time. It had to be commercial grade, which meant that we had to design something from the ground up, which we did. We built a drone that had over 50-minute flight time with a sensor on it. It was water resistant. And we designed it, and we had it built in China. We had it delivered from the building specifications to it arriving on our doorstep. It was 2 months. So we do rapid prototyping and rapid solutions in order to fix a person's problem. Another example is that we worked with the Oslo University Hospital with a project that they were running in order to understand when a person doesn't have the ability to communicate or talk, was becoming uncomfortable or agitated. So what we did is we looked at motion sensors and heart rate and galvanic skin response in a watch, very similar to the training watches that everyone is wearing when they're training now. And we wrote software that could capture that data and analyse the peaks to see if a person was becoming agitated. So from the time that we sat down with the customer and built the spec to when we delivered the final product was 16 days. So we work fast. But in order to work fast, in order to solve the problems, we have to understand where these problems exist. And if you don't know where the problem exists, it extends the amount of time it takes you to actually deliver a product that is suitable. We implement the solution. So we don't just build this stuff, but we actually look at how to implement this into your various processes so that it can be dovetailed in with minimum disruption. I mean, everyone here, likely throughout your career, you've worked for large companies, so you know the importance of change management. We see very good ideas being rolled out, but if the execution of the idea does not work very well, then it doesn't matter how great it is, people don't adopt this idea and it falls apart because people just aren't using it and they're not supporting it. And the thing is that people are not like a computer. They're not ones and zeros. You need to win them over, you need to do the marketing, you need to listen to their concerns, and you need to address those concerns. So we also work with the human component. And then we train organisations to do all of those things above. So we also do consultancy for large companies. We come in and look at what they've done, and we run business analysis, and we help them also to go from a theoretical product on paper to an actual product that's going to do their business some good. So what is big data? So what I'm going to do is I'm just going to turn that off for a second, and I'm going to ask you guys what big data is. I'm sure everyone here, with your combined knowledge, someone can tell me what big data is. There's no wrong answers, but there kind of is. But I'll ask you guys anyway. So who has an idea? What is big data? You don't have to tell me what the whole thing is. Everyone's heard little catchphrases about what big data is. You look like you know. You don't know?
Suggestion maybe it's something. It's depends. It's have an amount. The amount is huge or it's complex.
Yeah.
There's you cannot analyze it.
So volume is one of those things, and complexity. Yep. Any other suggestions about what big data is? What else is big data? Don't be scared.
It's everything.
It's everything? Well, technically that's right.
Something that can be explained in numbers or figures or
Yep.
letters or voice or...
Yep. So big data is information in all its forms, categorized and uncategorized information. Well, actually, that's a really good starting point. So big data is holistic information, so it's encompassing all the information you can think of. And it's a management strategy. So what it does is it integrates all different types of data into some kind of usable form. So what's very interesting with this is it integrates new types of data along with traditional types of data. And what's funny about this is when we were doing this software, it was actually an integration project for Oslo University. New types of data and a new way of measuring what the patient was feeling and thinking. So what was very unusual is all of a sudden confidentiality, and patient confidentiality became an issue, even though it wasn't a written report. And it turned out very quickly that patient confidentiality was never written with these kind of applications in mind. So it was a completely different way of looking at data and accessing information on the patient, which for most of us would be considered pretty much useless, but the laws of confidentiality that we have in Norway still apply to the information, which made it much more complex. So, you know, we have to operate in a framework that exists that may not actually be considering the kind of data we're collecting. So there are challenges involved with big data. So, as you said, volume is one of the big things. High volumes of granular data, and very often it's unstructured, which means that we get it in various different forms. It could be tweets on Twitter, it could be comments through YouTube, it could be what you buy on Amazon, it could be all different kinds of pieces of data. It could be from sensors that you have in your smart home, that you have that little thing that spies on you in your house and answers questions like the weather and all of those kind of things. All of this is big data. Some of it is structured, some of it is not. Velocity is the rate at which the data is both received and acted upon. So one thing is to collect the data, but the other thing is to use that data to make a decision and act upon it. The next thing is the variety. So we have new unstructured data types. These have the same requirements and considerations as I mentioned previously. And then we also have value. So what's very interesting is big data, sometimes we hear it referred to as the 3 V's, sometimes as the 4 V's, sometimes even the 5 V's. But I like to emphasize this part here, the value of the data. Understanding the intrinsic value of that data and asking the right questions. So this is the interesting thing about big data. You're asking the right questions, recognizing patterns and making informed assumptions and predicting behavior. Those last points there are very dependent on the human. Because without the human input there, the data is meaningless. It has to be acted upon, the decisions have to be made, models have to be built. You need to be able to compare real-life behavior and activities and the way something turns out compared to the models that we have built. So there is human interaction that is required for big data to function. So the history of big data is quite interesting. It actually goes back to tally sticks 18,000 years before Christ. So they found these sticks where someone owned someone, or someone owed someone else, like 3 camels or something like that. So they'd scrape the mark into the tally stick so they could count up what they had and what people owed them. So what's interesting about this is it was linked to business. Someone was keeping an overview of what it was that they owned and what someone owed them. Then after that, we had, and bear in mind I'm skipping a lot of stuff in between, John Gaunt and statistics. So statistics emerged as an area of study with this guy John Gaunt, and what he did is he looked at the number of people that were dying of the plague, and he understood that he could statistically measure this, and he could see if the plague was a real risk in certain population sizes. He was the first person to look at people as a number and look at the statistics and use that in order to infer and make predictions. We have Richard Millard Evans, who coined the term business intelligence in 1865. So he wrote the Cyclopedia of Business. So he coined that term, and that was connecting data with business decisions. Then after that, we had this handsome man, Fritz Blumer, and he created the magnetic tape, which allowed people then to store much, much larger amounts of data onto magnetic tape for long periods of time. Before that people were still doing it on paper. To give you an example of what a difference this made was when the Library of Alexandria burned down in Egypt, they lost about 3,000 years' worth of writings in history. But for the first time, you could back everything up on magnetic tape very, very quickly. This was a game changer. After that, we had the first large data center in the USA that was built to keep people's tax information and their fingerprints in case they committed a crime, or people who had committed crimes, their fingerprints were on file. After that, Tim Berners-Lee of IBM, he announced that the internet was now a thing, and then cat memes became very popular from that point on. After that, we heard the term big data for the first time, and that was in 1999, and then Web 2.0 came out in 2005. So who can tell me what Web 2.0 is? Anyone know? Exactly. It's user-built information and it's user-submitted information. So for the first time, we started to realize the value of users and consumers providing that information into a system and starting to store that information. And it was made possible because we had faster data streaming rates. People saw the real business opportunity there. Then big data, as we know it, started in 2007. And then big data became cool in 2011. Everyone started talking about it. And that's a very brief history of big data as we know it. So what's very interesting about big data and business intelligence is that people often refer to these two things as if they're one and the same, but they're actually very different. So on one side you have big data and you have the 4 V's. So you have volume, velocity, variety and value. Okay, so that's the data itself. But on the right, you have the organisation and the analytics of that data. Why? To gain valuable business insights, to use that data to some end that generates value. So the two are not the same. This is the tool. This is the result. So very often the two get confused and mixed in together. So part of what I'm hoping everyone arrived for today was to get some insight as to why big data projects fail and why some big data projects succeed. I've worked in a number of big data projects, and we've also done quite an amount of consultancy with large companies. And if I had to boil down the reason why these projects fail, I think I could boil it down to 6 core reasons. One is a very poor understanding of the core business. A lot of people show up to work day in and day out, and we had a conversation earlier about this. That's, a lot of people, and many of you guys sitting in this room, technically you're very, very competent. But if it comes to selling your idea and explaining the value proposition and being able to document the value proposition so you can sell your idea into your organisation, you would struggle. And it's completely natural because you've spent your time to become the best in your subject area, and this falls outside of that subject area. So this is a very common issue that we see when we're talking about big data. The next point is a lack of a clear business case for a big data application. If you don't understand your core business or your value stream, or what your value drivers are, then how can you actually implement a big data strategy or a big data product or some idea that you have that's actually going to make sense to your business? You will not be able to do this because you do not understand your business well enough. Maybe you're seeing some of the symptoms and some bottlenecks or barriers that you have in the value stream, but you do not understand the root cause of what is actually the issue. So if you try to execute a project at that point, or even develop a project, you will fail because you have not actually identified where those bottlenecks lie. So because of that, very often people have the wrong drivers. And nearly everyone here is an engineer. I'm not an engineer, but I'll pretend that I'm one because I've worked with you guys long enough. We love tech. We love the cool stuff. We love to play with the things, artificial intelligence. It's cool stuff. Collecting this information, being able to manipulate it, this is fun. But this isn't what actually adds the value. The value is added when it's solving some problem that's causing pain to the company. And because we don't actually understand these drivers and we're in love with the tech, we end up with the technology in a neat mismatch. We either go with the wrong platform, we go with the wrong kind of information, we go with the wrong algorithms because we don't actually know what problem it is that we're solving. And nothing is worse than a solution to a problem you don't have. After that, we have a lack of expertise. Like I said, we're in an engineering world. And very often what happens is a company has a lot of engineers, or it might have a lot of farmers, or it might have a lot of chemists. And so when they see a problem with the business, they think, okay, we need to throw more chemists at this problem to solve the problem. Well, if chemists could solve the problem, it would already be solved because it's a company full of them. People need to take a step outside their organisation, outside their comfort zone and what they know, and look to people with the business expertise to see where the issue actually is. And after that, even if you succeed and you have a really great idea and you have a really good project that's collecting the information, you're doing a lot of modelling and your predictions are turning out very accurate and you implement those changes, unless you exercise a change management strategy so that people will adopt these strategies that you have and they'll take care of this system long term, it won't work either. And we've seen that. We've seen a lot of, say, search engines. We've seen a lot of search engines that came and went. Now we're seeing software in our companies that started out really strong. No one adopted it. They didn't see the point. So making big data work. Big data is just a tool. On its own, it doesn't actually achieve anything. And in fact, there's so many different ways of doing analytics. You can do business analytics, you can look at modelling with regards to, say, a physical object. There's all different ways of using information and data to create some prediction or a model. So you have to understand your problem in order to apply the correct tool. So I really like what Hans-Peter Lund said here, and I believe he was a researcher for IBM. Business intelligence is the ability to apprehend the interrelationships of presented facts in such a way as to guide action toward a desired goal. If you don't know what the goal is, if you don't know what your root causes to the problems and bottlenecks and barriers that you have, there's no way to solve the problem. There is no general fix for this kind of thing. You have to be very specific. You have to understand exactly where to focus your efforts and your money. So, what I'm going to walk you guys through now is a process that we follow. And I'm going to keep it very, very general because there's all different ways to run a business analysis. There's all a bunch of different ways on how to build a business plan. But I'm just going to keep this very high level and general because we use all different kinds of tools when we're doing this. And I don't want to eat up the time of these other guys that are going to present. So one of the first things we have to do is we have to measure the current state. So we have to be able to map what is currently going on to see what we have in front of us. And it's quite interesting because a lot of times people come from an industry and you say, okay, well, let's do some value stream mapping. Let's see the verticals, starting all the way from your sub-suppliers, going all the way to your end user or customer, and let's map this out. And it will take you a week if you're good at it. Because people don't really know their own value stream. It will shock you. It will absolutely shock you. I know I've got Bruce sitting there and he's having a bit of a laugh because he's done it before. I've sat in meetings where it's taken 2 weeks to actually map a value stream because people don't know their business. So one of the first things that we do is we actually define what a value stream is. So we give an example and we show people, look, this is what a value stream is, this is how it looks when you map this out, and then we work through the entire value stream. And you can work vertically through the verticals of your value stream, and you can also work horizontally. And you may have a bunch of different industries or a bunch of different departments that share common suppliers and things like that, and they may have the same vertical. It looks very, very similar. So you can have a horizontal and you can have that vertical on the value stream. So what we do is we map the value streams after that. We identify the cost and the profit milestones in these value streams because we need to know where is the pain. If you have a problem, the problem has to cost you some money. So one of the ways that we ask that question is we say, okay, what is the solution to this problem that you have now? And they explain to us. And then our next question is, why is this not the ideal solution? And if they say, well, it's the perfect solution, or if they explain why it's not the ideal solution, then we go, okay, how much money is it costing you to have this solution now? And if they're paying a fortune to try to solve a problem and it's not ideal, then we know that there's actually the ability to come in and solve this problem because they're willing to spend money and it's causing them some pain. And we use this line of questioning time and time again, and it works. After that, we identify a value stream that we want to improve on. Big data is a scalpel. It's not a broadsword. We need somewhere to focus and we need to understand where that problem is because we need to go in and we need to look upstream and downstream of that problem and start collecting information. Because when we make a decision, that decision is going to show up in the information that we're capturing, in that data that we're capturing downstream. So we need to know exactly where the problem is so that we know where to start collecting the information. Then after that, we prepare for a brainstorming session. And we do that by creating an overview of the potential improvement that we want to execute in that company. Is everyone with me right now? Yeah? If there's anything you don't understand, please just put your hand up and ask, and I can explain to you more as well. Right, so what we like to do is we do something called a brainstorm or a business deep dive. We do this in order to map the value stream so that we can identify synergies that we can see across the board. We can see that we can capitalise on the work that we're doing and we can see some synergies that we can build. We know that we have potential for a good project and it's going to make good business sense. So the deep dive concept is quite interesting. Has anyone ever heard of deep dive being used before as a term? Yeah? No? Would you care to give us some information on what the deep dive is, if you remember? You don't have to be shy. You nodded your head up there as well?
Now it's about getting more detailed overview.
Yep. It's a way of brainstorming. I've made a few notes here to just talk you through here. But it's a 5-step process, and it was pioneered by a company called IDEO. They're the design company that actually invented the mouse. As we know it, they designed the first microwave. They did all the design work for that, and they pioneered this way of brainstorming. So the 5 steps are broken down as such. Step 1 is to understand the market, the client, technology, and the constraints. So you can do that using a SWOT analysis or Pre-Know-F. There's a bunch of different tools that you can use for doing this. The second step is to observe real people in real situations that are affected by the problem that you're trying to solve. So it's not theoretical. You're sitting with the people, you're trying to solve it. Next step after that, step 3, is to visualize new to the world concepts. So you're looking at concepts that have never actually been put out there before. And what you're trying to do is you're trying to see how the end user or the customer is going to respond to these concepts. Point 4 is to evaluate and refine your prototypes based on that feedback. And point 5 is to implement a new concept for commercialization. So the key point there is commercialization. If you don't have an idea, or if you're not solving a problem that has commercial value, then it's a waste of time. None of us do this for love. We hope that there's some payback at the end of it. So basically what you're doing is you're joining the dots between silos and identifying improvements for existing support systems. BigData is there as a decision support system so that someone can make a good decision that's going to generate extra income or reduce pain in that value stream. And what you're trying to do is you're trying to identify the possible synergies and build the framework for a business case for that particular value stream that you're looking at. There has to be a business case attached to this. And this is something that we often miss. Now, if I was going to ask everyone here, and be very honest, who here has had a brilliant idea that they have proposed to their company in the past? I have. Let's see who else. Don't be shy, don't be shy. Yes? Yes? I think that'd be most of us. Okay. Who managed to get that idea adopted? Some of them I got adopted. Who's got all of their ideas adopted? Yeah, very few. Very few. It has to be linked to a strong business case. And one of the things that I have done a lot in FMC is I've spoken to product responsible engineers and subject matter experts in a business case and how to market their particular idea. I know Jon Wilson and I, we worked on this together in the past. We sat down and we looked at how to do this from a human point of view, from a change management point of view, rather than a technical point of view. And the two sides are just as important as each other. So the end result after doing this process is one mapped value stream. After that deep dive, that's what we want. We want to focus on one particular value stream that we see the most potential in. If you spread yourself too thin, it's not going to work. So we drill down. We start broad and we're starting to narrow down where our effort should be placed. So what we then want to do is we want to identify these particular synergies. So step 1, we start to develop concepts on how we're going to improve that value stream. So we develop these ideas and concepts specifically to look for synergies, ways that we can make improvements. Step 2 is we look at the kind of information that we need. What information do we have on hand? What information don't we have that we would like to have? Where is that information located? Where is that data? Who owns it? These are really, really good questions because a lot of the times we think, we have a great idea, but how do we measure whether or not that idea is going to take off? So after that, we like to prototype a solution. We've narrowed the concepts down. So what we do is we create a mock-up or a prototype. So the reason we do that is to get the leadership buy-ins because we have to show a tangible example that people are happy with. At the end of the day, it's the leadership that sign our paychecks and decide whether we have a budget for these kind of activities. So this prototype will dictate if the project will continue to an implementation stage or if it gets cut down straight away. So what you want to do, from all the other steps we spoke about to here, you want this to be quite rapid. Because if it gets shot down at this point, then you haven't spent a lot of time and money to get to here. But you've done the homework. If you skip those steps, you'll get to here and you'll roll out a product that nobody needs and it costs you a lot more money. So everything is grounded into the business case. So what we then do is we create a set of criteria to rank the concepts and the proposals that we have. We select one to take into the prototype. Again, we revisit the business case and check that it's actually still economically viable. Does it still make sense? We keep going back to the business case. Then after that, there's a decision milestone. Do we develop this further or do we just can the project? And when you can the project at that stage, if you do the process correctly, you don't waste a lot of time and money. You end up being able to roll this out quickly. And it might be the case that management say, hey, our focus has changed, we're not interested in that anymore. But once you've been through this process 1 or 2 times, you can always go back and you can analyse another value stream and you can make another proposal. It's just a skill, it's practice, and the more you do it, the better you're going to get at this. So after that, we develop an operational solution. So what we do is we add detail and resolution to this prototype. You know, we've got an idea of the prototype, how to build it. You know, now we actually want to start to run a pilot. So again, we revisit the business deep dive. So it was step 2. We readdress these operational environment constraints that we have. After that, we finalise the business case. We build an organisational structure. We develop the plans, identify milestones, the budget, all of these things. And this is where it's very interesting. How many times have you guys been in the company and the first thing that we do is build an organisation, then we decide what the heck we're going to do with all these people? Yes, it happened a few times. Yeah, we've got some senior people here. They've seen this happen a few times. Yeah. So what we're saying is you shouldn't make any move until you actually understand the business case for it. Once you understand the business case, all these other steps here, these are tools. Your business, your organisational structure, your development plans, all of these things here, these are tools to measure your progress, and these are tools to help execute the business case that you've developed. We conduct a pilot and test to check feasibility, and then finally we revisit the solution, the benefits, the decision milestones, and we look at the pilot results to see if we wanted to go with a full-scale rollout. So the development of the operational solution includes all the previous steps that we spoke about. And it's the stage where the pilot is conducted and we look at additional bottlenecks and barriers because now it's where the rubber meets the road. We're rolling it out on a small scale. So we're going to see symptoms of where we have issues in the company. And the pilot is very, very important to be able to identify those. So the next step is to implement the solution. And this is where the change management comes into this. So with this decision made to conduct a full rollout, you know, we're looking at a full-scale rollout now, and this comes up, it shows up a lot of challenges in our organisation, usually in the organisational structure, because people want to protect their area of interest. And this is most of the time why these kind of initiatives, and just, I mean, we've taken the detour of big data. We're not even talking big data anymore, we're just talking business in general, any change we want to make. And big data, as sterile as we think it is, because it's collecting information from sensors and collecting information from customer buying habits, as soon as it has an impact on the organisation and the people sitting within the organisation, then people start to matter more than the information because they have the ability to either derail or to get behind this decision that you're making and change the way that you do your business. And it always boils back down to the people adopting this idea. So how do we do it? Well, we promote the solution, we update the routines and the processes, we train people, and we get people organised, and we get their concerns, and we help to address their concerns. And we dismantle the old routines and the old processes, and we pull these things down so that people can't go back to the old way that they used to handle it. So that it's like, I believe it was Alexander the Great, he landed his ships on the shore, and then he burnt them, so that people couldn't go back the way that they had come. And then he said, right, if you want to go home, you have to fight your way forward. There's no way to go back home safely. Maybe a bit extreme, but it worked for him. So what's very interesting in all of this is that if we look at the Department of Health in England, they found that 15% of the transformational programs achieved their goals. Only 15%. They spent billions to roll out new types of storage new ways of doing analytics, new ways of scheduling. Only 15% of these projects succeeded. And the reason why, when they did the analysis, they failed to take into account resistance to change. People don't want to change. They want to do things the old way. They're not willing to adopt a new way of doing things. So here we go. We're talking about high-tech, big data, artificial intelligence, all of these kind of things, and it gets derailed by the people who have to roll it out because they like doing things the way they used to do it. So the human component breaks something that could have worked. So 20% failed to achieve all their objectives, but they said, yeah, it was still good enough. And then 65% of these transformation projects failed completely and were considered totally unsatisfactory. Billions of pounds later. So once you're running your pilot, once you do your implementation, any steps that you do, you follow the same step. You plan, you establish your objectives and processes for your outcome. You implement your plan. You check, you study your actual results, and you compare it against your predictions and the models that you've built. Then after that, you act. If you see that an improvement was made, then this is how your organisation should be acting moving forward. And I believe it was Socrates that actually came up with this model. It's only a few thousand years old and it's still working, so it's a fairly sound principle. So, I'll give you guys an example because I know Gunnar was asking me about a concrete example of how big data actually works and how it can implement change. So this example here is actually small data, but it had a huge impact. So it doesn't always have to mean huge volumes of data. Sometimes it can be small piece of data from different segments or different industries. So this gentleman here, Professor Orly Ashenfelter, he loves wine. He loved wine so much that he wanted to figure out how you could predict the price of Bordeaux wine. Because if you could predict Bordeaux wine accurately and its pricing accurately, then in 10 years' time, it was one of the best investments that you could make with your money. You had a much better return than real estate or anything else. And all the experts said, no, you can't make a model like this because it requires the human smell and it requires our taste and expertise it's gained over years and years and years. And he said, okay, well, we'll see about that. So what did he do? He studied a number of different segments of data. First of all, he looked at the winter rainfall. So the Bordeaux wine that was priced the highest, he went back and looked at how much rainfall was it in the winter. What was the average summer temperature? What was the harvest rainfall? And what is the age of the vintage? And he combined all of that, and he added that to negative 12.15, and he gave him the price of the bottle of wine. It's a 94% accuracy every time. He destroyed the industry. These wine snobs were sniffing their glasses and, pretending, well, not pretending, they had skill. Well, let's be fair. I would love to drink wine all day as well. But these guys had skill, and they would use this skill to predict the price of the wine. But the reality was an algorithm or a formula like this could do it much more accurately than they could. Is that what you're kind of looking for, these kind of examples? Okay. I have one more example here. This one here is closer to home because this is a job that I actually was involved in. I was a project manager. I designed this project and I executed this. This was for Central Queensland University and the Rockhampton campus. So the problem was this. We were looking at building a building which was going to cost us about $57 to $60 million because we couldn't get lecturers. We couldn't get lecturers into auditoriums. They were always booked. So they said, look, we need a new building. This is no good, we're having a backlog of these lectures. So they called me and they said, right, we need you to go and have a look at this because we need to figure out how big this new building has to be and how many new lecture halls we're going to need. I said, okay. So I was going around, and I was very young at the time, but I was going around and my job was to count people sitting in a lecture room like this. So I'd come and I'd stick my head there, I'd look through the window, and I'd go, 1, 2, 3, 4, okay, 16, and I'd write the number down. After 2 or 3 days, I couldn't handle it. I went back to them, I said, this is nuts. What are you guys doing? I said, this doesn't prove anything. And the old guy that I was working for, he was so close to retirement, he couldn't care less. So he just said, well, you know what, if you're so smart, you come up with a better proposal, and let's see what you can do. So I went home that night, and I worked until about 3 o'clock in the morning. I drafted down how this should work, how the modelling should look, the different constraints you need to look at, and the different considerations. And then I came to him with a business proposal, even with a return on investment calculation. And he said, that looks wonderful, it's your project now. And so he spent the rest of his time until he retired sipping coffee, and I did his job for him. But it worked out really nice because I was looking for the root cause of this problem. These lecturers that couldn't find rooms, this was a symptom. I wanted to know what the actual problem was. So what I did, I looked at student enrollments that came into the enrollment department. I looked at the time of year, which semester it was that these classes were being scheduled. I looked at the lecturer that was booking the room and what their preferences were with regards to the rooms that they booked. And then I took into consideration the student laziness. Because if it was a class that was very, very early, in winter when it's cold and people don't want to get out of bed, then people didn't want to show up. And so I combined all of this and I created some models, some predictive models. And in the end, what it turned out that we were only using the rooms that we had at 16% efficiency. The rest of the time they were sitting empty. So what we found, that there was actually a reduced need for auditoriums. We had too many as it was. So what we did is we started to funnel these people that like to be in a nice big auditorium with only 5 people into smaller rooms. So what did that do? Well, that meant that we had a reduced maintenance cost. We didn't have to clean the auditoriums as often. We didn't have to do repairs as often. And also, I introduced a streamlined room booking system and a maintenance system which saved them a fortune. So at the end of the day, what we ended up with was about a 44,000% return on investment for my 2-year project. Not too bad. Saved them a fortune. And when we did this and we implemented these measures, we were the first university in all of Australia to have an automated space management system and automated maintenance system. So we had to register all the information such as the light fittings, the type of paint, the handrails, all this kind of thing. But if something was damaged, the lecturer could send an SMS and it would get automatically routed to the guy in the warehouse that would put the stock aside, and then the tradesman that would have to fix it would get an automatic SMS that the stuff was ready for him to pick up and he would go there and fix it. So we reduced the time from 4 days to fix something to 3 hours. So my return on investment didn't even calculate the time savings for the maintenance. That would have looked even better, probably about 52,000% return on investment. It wasn't big data, it was just data from a bunch of different areas that was combined to build a model, which solved the root cause. It didn't solve the symptom, it solved the cause.